All right, let's look at Green's theorem. All right, Green's theorem goes like this. All right, double integral over region A of partial derivative q with respect to x minus partial derivative p with respect to y with respect to dx and with respect to x and y is equal to the line integral along the boundary of the same region A, p dx and the q dy. Right? So let's prove this. Right, so I'm gonna just look at the special case to make life a little bit easier, and I'll just do the one half of it. The other half is going to be very, very similar. Right, so I'm going to establish this one. So left hand side, this second term, so it's negative partial p with respect to y. Then integrate a double integral over that is equal to the line integral of p dx. Right, so let's try to establish that. So that's equaling that. Right, so let's start with the left hand side. So left hand side, and I'm gonna assume that the region A can be bounded by lower curve L and an upper curve U. So it's a region bounded by two curves, and going from x equals A to x equals b. Right, so let's set up the integral here. All right, so we have so this is going to be a double integral. All right, and I think it'll be easier to do integral with respect to y first. So I'm going to have a negative partial derivative p with respect to y, with respect to y first, and with respect to x. Right, so for a fixed x value, so since we're doing with respect to y first, we fix x, and you can see that it's going to start from on the boundary, lower boundary curve L, all the way up to upper boundary curve U. So I would put, so this is going to be y equals L of x to y equals u of x. Right? Then, to cover the entire region, you would have to start from x equals a. Then you would cover x is gonna go increase and all the way up to b. So x is gonna be equal to x going to be equal to a to x equals b. Right, so this would be the left hand side of the equation. Right, let's see if we can get the right hand side. Right, so using the fundamental theorem of calculus, we can work on the inner integral here. Right, so this is going to be equal to integral from x equals a. I'm going to just write the a there. Right, I think it's not confusing. So from a to b. Right, so by fundamental theorem of calculus, so take the antiderivative of that, and luckily this is already a derivative, so it's going to be a negative p x comma y. Then maybe I'll be simpler. Right, so it's a negative p. Then you're going from L of x to I should write y equals L of x, y equals u of x. Right, and then dx. Right, then this is going to look like this. So plug in the top one, you will get so integral from a to b. Right, this is negative p. Right, so x comma, plug in the top one, u of x. Right, so this is p is a function of two variable x and y. All right, and minus, and there's already a negative sign, so get plus p. And then x comma L of x dx. Right, And I'm gonna split into two parts. So here, right, I'm gonna write the second one first. So this is gonna be an integral from a to b, p of x comma L of x dx, right? And I'm gonna put I'm gonna incorporate the negative sign to flip the lower bound and upper bound. So I'm gonna put b on the bottom, a on the bottom. So by incorporating this negative sign, then you have a p of x comma u of x, right, dx. All right. So this is going to be a line integral. First integral is along the curve L of x, and the second integral is along the curve U of x. All right, let's see how it goes. All right, so if you're going, let's say, from A to B on L, so it's going to look like this. Right, so you're going to go along the lower curve. So you're actually going along the curve this way. Right, so that's the first integral. Right, how about the second integral? Second integral is actually going from, let's say, B to A and along the U curve. So it's actually, because starting from here, you are going along this upper curve and back to A, right? So you can see that as you combine these two line integrals, you actually make a complete, go around the edge of the region A all the way once. All right, so this is going to be the line integral along the, since it goes all the way around. So here's a notation. So it looks like a partial derivative. So partial of A, this is the boundary of the region A. Then we integrate this P function, P function dx, right, which is exactly the right hand side, right? So this completes the proof for the 1/2. Then number 2, you would have to still show that double integral over the same region A, partial of q with respect to x, dx dy is going to be equal to the line integral along the boundary of A, q with respect to y. And the proof is very similar. So I'm going to omit that, but we can establish the other half as well. So that will establish the proof of the Green's theorem, right? So Green's theorem is just the use the fundamental theorem calculus to take care of the inner integral. Then we basically put the two integrals together to get the one big line integral along the boundary of the region A. All right, that's it. I hope that this was clear.